Here is your extra example. So if you remember from class today, the very first thing that you want to do is you want to set up your augmented matrix. So across the top, 4, -3, 1, and across the bottom, 3, 2, and 5. So the first thing we want to do is we want to add two of the rows together so that we get a 0 in one of the correct places. So we either want a 0 in this position right here, or we want a 0 in this position here. And in this case, it doesn't really matter where you get it, but we are going to have to multiply, because if we were to add these two together, they wouldn't add up to 0, and adding these two together does not add to 0. So what we have to do instead, and I'm going to underline this one, so we will get a 0 in this position right here. So in order to get these two numbers to add to 0, we would need to multiply everything in this row times 2, and everything in this row times 3. And because we want the 0 to be in this position, this is the row that we're going to change, and this is the row that we're going to keep. So automatically what we can do for our next matrix is we can automatically write down that bottom row, because we know that that's not going to change. So up above, I'm just going to write what the new number would be after we multiply everything by 2. So this would be 8, this would be -6, and this would be 2. And then down here, I'll write the numbers after we multiply everything by 3. So this would be 9, this would be 6, and this would be 15. So now we're just going to add the orange numbers from the top with the orange numbers for the bottom to get our new row. So down here we have 8 plus 9 is 17, -6 plus 6 is 0, and 2 plus 15 is 17. So remember, our goal is to have our matrix be the identity matrix on the left and the solutions on the right. So we've got this 0 taken care of. So now what we need to do is we need to get a 1 in this position right here, which means right here. So to do that, we just divide the whole row by this number right here. So divide by 17, divide by 17, and divide by 17. Notice again, this row is still not changing. So the bottom is going to be 3, 2, 5. And now the top turns into 17 divided by 17 is 1, 0 divided by 17 is 0, and 17 divided by 17 is 1. So now we have our whole top row taken care of. We have a 1, a 0, and we have the solution for our x. So now the next thing that we need to do is we need to get a 0 in the other correct position. So the other position where the 0 needs to be, if you look at your goal up here, is it needs to be in the bottom left. So we want this one to change to a 0. So that means that this is the row that's going to change, and this is the row that we're going to keep. Okay? So when we add these two numbers together here, they need to add up to 0. Well, 1 plus 3 does not equal to 0, so what we would need to do is multiply this whole row times -3. So times -3 times -3. So again, because we're keeping this row right here, when we write our next step, we can automatically write that top row. 1, 0, 1. We're not doing anything with that top row. Once we get this goal reached, then we don't want to change that. Okay? So again, I'm just going to write up above what's going to happen when I multiply everything here times a -3. So this would be -3, this would be 0, this would be -3. And now we're just going to add these orange numbers here with the bottom row here to get our new row down here. So -3 plus 3 is 0. 0 plus 2 is 2, and -3 plus 5 is 2. So if we go back up to what our goal should look like, we have a 1, a 0, We now have another 0, so all we have left to do is get a 1 in the bottom left-hand corner, right here. So all we have to do with this row is just divide everything by whatever is in this position. So divide by 2 here, divide by 2 here. Again, top row is not changing, it's just the bottom row. So we would have 1, 0, 1, and 0, 1, 1. So that means that the ordered pair, this remember represents X, and this remember represents Y. So our ordered pair would be 1, 1. And if we go back up, we can check this by plugging the X and the Y from our ordered pair into each one of these equations here. So if we have 4 times 1 minus 3 times 1, it should equal 1. And if we do 3 times 1 plus 2 times 1, it should equal 5. So here we would have 4 minus 3, which is 1. So we know that that one checks out. And 3 plus 2, we have to check to see if that is equal to 5, which it does. So we know that we have done the correct, we have the correct answer here. We've done the problem correctly.